Well, how you doing? Okay, you might hear me cough a bit. I have a bit of a chest infection thing going on. I might sound a bit chesty. Okay, this is a response to Bob the Science Guy. Uh, he was making a claim recently, or past while. I've seen it, and I kind of let it go. I've seen it, and I didn't do anything about it. I didn't pay much attention to it, but I kept hearing this claim, and he was making it on Bev Try Thinking server and different places. Or that's why I'm hearing a lot about it. So I said I had enough of it. I'm just going to call it out for what it was, which was dishonesty. Bob is using the Haversine formula. Okay. Now I had two in my last video, which I will link in the description, and I will link Bob's response to me in the description of this video. In my original video, I pointed out that the Haversine formula requires an OR measurement. Okay. And he's using it in relation to, it's used in relation to the globe Earth. But we don't have any OR measurement to the Earth. We have a flat plane. We don't have any proof of a globe. And the main proof of a globe would be an OR measurement. We don't have it. It's a mathematical position, an imaginary position that is in the mathematics, even admitted by celestial navigation, who've known, it seems, for must be decades, centuries, that this geometric horizon that they mathematically do a dip to doesn't exist, because they call the actual horizon, the only one we know, they call that the real horizon. And after they do their dip to past the real horizon to their geometric horizon, their mathematical horizon, they then do height of height correction, which brings that line back up, and the line from the observer's position down below the boat, and they end up with a horizontal line across a flat Earth. That's what you end up with. So this geometric horizon doesn't exist. It's only in the maths, even within celestial navigation. So that was the only way that it was claimed that this OR value was ever measured. And this was by Alberoni, and he supposedly measured from after having to measure a mountain using flat Earth, using a flat Earth, having to pre-assume the Earth was flat to measure the height of the mountain he was going up onto in Nandana in Pakistan. He then had to go up and pre-assume that an astronomical and geometric horizon were real. And so he never measured anything. He pre-assumed, it's even said officially, he pre-assumed it was a globe, and he used supposedly the maths of Pythagoras. Now, what Eratosthenes did was he measured a portion of a flat diameter to the Earth. And he had to then, and it's officially admitted, he had to then pre-assume it was a globe. And to make the shadows work, he had to pre-assume that it was a globe and that the sun was a certain size and distance, and that we had parallel sun rays. Now, nobody has ever photographed or videoed or seen parallel sun rays. They don't exist. So they were just two pre-assumptions. No one ever measured this OR value. So the Haversine formula is moot. It doesn't mean anything, because it's only just used as a belief, a kind of like a confirmation bias. It doesn't mean anything in the real world. It's only a mathematical thing. Now, as a mathematical formula, it works. No problem with it. I didn't state I had a problem with it in my video. I just called out Bob on the use of it and how he was using it. As he was using the run line of this of the Haversine formula, he was claiming that as a flat Earth or flat plane a surface distance measurement, when it's not. It's a line, basically a chord through a circle or a sphere. So it has nothing to do with the surface, a straight line surface horizontal distance measurement, nothing to do with any of it. But he was using that and claiming that, and then using the Haversine formula to show how, when he'd used the Haversine formula, that it was his final outcome was more correct to the actual distance. distances he was talking about. But the whole point of the rhumb line is that it makes a straight line through a circle, and then you use the Haversine formula for the correct. Let's just say if you want to use a globe projection, you get the correct distance. Let's say whatever direction whatever you're looking to measure, part of a continent or whatever, by using the Haversine formula, using a radius. But there is no radius; it doesn't exist. So it's just a belief, a mathematical belief formula. It has no, like, the only part of it that connects to anything in reality is the distance it measures. But in reality, that distance is a straight line. It's not a rhumb line. The rhumb line is not the distance. It's just through the use of the Haversine formula, you're using a radius. So you're making it a globe. But that doesn't mean it's a globe. It means mathematically you can use the Haversine formula to make a globe out of it. But anyway, we'll move on, right? Because I have a little bit of reading to do and stuff. So this is a mnemonic projections, right? A mnemonic projection is a map made by projecting points and lines from a globe onto a piece of paper that touches the globe at a single point, right? Mnemonic projections distort direction and distance between land masses. Mnemonic projections are useful in plotting long-distance trips by air or sea. Now, they claim, like they admit that, or they say it these distort direction and distance, but they also say they're useful for long-distance trips by air or sea. Why are they useful? Because they make the Earth flat. That's why they're useful. Because you can't navigate with a globe. There is no flat Earth map because no cartographer seems to ever want to make it. They make every single thing they can make. They'll make the Earth flat, and they'll always be starting off with a globe, and they'll do a flat projection off of a globe because they need to have flat, and they'll know where the distortions are, and by doing all this they can then make it back into a globe. But none of them actually have ever made a flat Earth map. Why won't they make a realistic map of the world? Why did they avoid it? They make conal maps. They make just go here. They make where is it gone to? Here. No, not this one. Where is it? Is it here? I must have moved it on. But either way, the point is that they make a flat map, and then they can use XYZ type coordinates, Cartesian flat coordinates, right? And they can use latitude, longitude, obviously, as well. But when it comes to the globe, they can't use any of it, right? They have latitude and longitude on it, but they can't navigate with it. You can't navigate with a globe. You have to use flat maps. There's no way around it. You can't navigate with a globe. If you could, they would be doing it. You know, if it was easy to do this, you would do it, but you can't because the globe is not the reality. So the mnemonic projection, this is used for, the reason this is used for, or I'm showing this, is that I'm showing what they do, and this is used for great circle routes. Okay, the mnemonic projection is the best projection for great circle routes, what they call great circle routes, right? So for a great circle route, the best projection is flat, right? That is it. They need to flatten the Earth, right, to use these great circle routes. So it's nonsense, but we're used to it. As I said, show it here, right? Once they flatten the Earth, they can use XYZ if they want, right? Because Cartesian works then, right? So the map plane, they have to take the globe and flatten it. And how they do it is they'll take the polar position, let's say the North Pole, and they flatten it down, right? That's what they do. This is a kind of a representation of what they do. When it comes to great circle routes, you will often find lots of projections showing the north and the North Pole and the whole north of the globe. Let's say this is the North Pole here, and this is their Antarctica down here. You'll find lots of projections like this where they show the northern part of the world, anywhere north of the equator, and you'll see it as a projection. But then you'll often see a lot of let's say similar projections where it'll be sectional, where you might just get a part of Africa or Philippines or whatever, right? And they do have Antarctica-based projections as well, but they only show a small little bit of the tip of Chile, and you don't see much else, right? So, but you will mainly see north projections where they flatten it out using basically an AE map type map, right? Now they don't use the AE map for this because it has to be more precise, so they use sectional maps, right? But they will use the north. They will use the north, but they won't use the south, right? Even though they have an Antarctica map, they don't really use it, not to the same degree. They mostly use sectional, right? So either way, they have to flatten everything to make it work. To use it, they have to flatten it. That's the point, right? And this is what this is how great circle routes, this is what they do. They need to flatten out their globe to use these great circle routes, right? So here is a more in-depth, realistic one. This is more precise. And this is one they could actually use. I think this is one of those projections, one of these mnemonic projections, where it has a lot more detail to it and blah, blah, blah. And this is only one. You'll obviously have, this is obviously in a book or something. You'll probably have a book of maps and you'll go on to the next page and there'll be the next section over here. You'll see over this part or over that side of the US or what, this is this kind of US and Northern Canada here. So this is what it looks like. Here is another one, right? This is, once again, this is Ireland down here and you have Northern Canada and all that over here. So once again, a northern projection, right? So these are what those maps are. These are the ones they will use for great circle routes. Probably, I don't know. I don't think I ever saw. I don't know if I've ever looked at a whole lot of flight maps and stuff. But I wouldn't say they'd be. I would sure and pretty much sure if they're using great circle routes that they're going to use these type of maps. These may not be exactly the same as flight maps because they obviously have other things on it, but they will be using these type of maps, and they'll be sectional. They might have a section for maybe this part of Europe and another section for the next part, and blah blah blah. Right? We get it, right? But the point is, they have to flatten out the Earth, and they have to flatten everything to use their great circle routes. Right? Great circle routes are a joke. Nobody can fly a great circle route and end up back where they started. You'll end up somewhere else. There's no way around it. So now summarize why great circle routes are commonly used in navigation, right? So this is one of the best I've found because it shows so much detail. These are all the parts in it. So I won't read all of it because there's some parts you won't need to read and it'll get a bit tedious, right? So I'm going to come down here to what are two benefits of the great circle route if you are a pilot. This route is called a geodesic or circle route. While map projections distort these routes, confusing passengers, the great circle path is the shortest path between two far locations. This is why pilots fly polar routes, saving time and distance. And this is why pilots often fly over Greenland, right? Often pilots fly over Greenland. I'm pretty sure I flew over Greenland. I wasn't flying the plane, but I was a passenger. I'm pretty sure I did once or twice. And the thing about it is I don't know hear of anyone flying over Antarctica, but you hear a lot of people flying close to the North Pole, Greenland, but you never hear people flying over Antarctica. They just don't do it. Never does. I never hear of anyone doing it. There was one flight from Sydney to Johannesburg that Qantas used to do, and the route they claimed to take was along kind of along part of Antarctica. But the problem with it is that when you do the declination on this flight, even though they're claiming this, they could never actually show and prove it. And I looked into it, and when we do the declination on this flight, Sydney and Johannesburg are over 2,000 miles, if I remember correctly with the declination, further apart. So when you do the magnetic declination, it makes Sydney and Johannesburg 2,000 more miles further apart. And also, they claim to leave Sydney and go to Hobart, and they were claiming to go south. But the thing about Hobart is when you do a declination between Hobart and Sydney, Hobart is far more east than it is, much more east than they were leading people to believe. It's not directly south. That's the problem. So, when you start doing magnetic declination on a lot of things, these claimed routes and all that they take, it's like the claim was they were leaving Sydney going south over Hobart and then flying towards kind of part of Antarctica and then up along to Johannesburg. But that wasn't what was happening, because if they were flying to Hobart, then they were going east, whereas Johannesburg was west. You know, there was a few things that at one point up, they were up near Perth, I think. The whole thing is all convoluted. But anyway, they don't fly that flight as far as I know anymore. So that flight is no more. The only other flight where they're going from Australia to South America is to Santiago. Now, I've seen different routes for that and different reasons for it. And the thing about it is that how come they're not flying to Mexico City? If you want to go to Mexico City from Sydney, you go to San Francisco, Los Angeles, Denver, and then you fly to Mexico City. Whereas you should just be able to go straight to Mexico City. Mexico City is bigger than any of those other cities. Bigger than Los Angeles. It's bigger, more people. You probably a couple of those cities could go together to make up Mexico City. Why aren't they flying directly to Mexico City? I couldn't find in 2019, 2020, I haven't looked, or 20 and 21, sorry, I couldn't find any direct flight from Sydney to Rio. That doesn't exist. Why are they not flying to Rio? I mean, Rio is a massive city. It's one of the most well-known cities in the world. It's huge. Why are you not flying directly to Rio? Like, the whole thing is all convoluted. So you can't trust any of it, right? All we know, right, for definite, is that they have to flatten out their maps to use these Great Circle routes. And not one of these pilots, no pilot, has ever flown a Great Circle route and ended up back where he started. Wolfie can't leave Sydney, fly and follow a Great Circle route and end up back at Sydney. It won't happen. You know, it's total nonsense. But anyway, we'll carry on. So that says why Great Circle routes are used in navigation. Okay, two benefits of Great Circle routes if you're a pilot. Sorry, there we go, just read that. Flying over Greenland, not over Antarctica. Let's see, why navigators and aviators follow the Great Circle route. The most famous use of Great Circles in geography is for navigation because they represent the shortest distance between 2 points on a sphere. Due to the Earth's rotation, sailors and pilots using Great Circle routes must constantly adjust their route as the heading changes over long distances. Right? What that means is that the north heading changes, basically, because I won't go into it all now. But if you look at why magnetic declination happens, their claim about why it has to happen, and the action, and if you look at how it would happen on a flat plane, then it makes far more sense, you know. But anyway, that's a separate issue. What benefits does following the Great Circle route give in global travels? What benefits does following the Great Circle route give in global travels? The benefits are shorter travel distance. It does not mean that the trip will be necessarily cheaper or faster, since following a Great Circle obliges you to follow the shortest course no matter what landforms and weather conditions you will meet. What are the main characteristics of the Great Circle? The main characteristics of a Great Circle are: a great circle is the largest circle that can be drawn on the surface of a sphere, of the Earth. Many numbers of great circles can be drawn on the surface of the Earth. A great circle divides the Earth into two hemispheres. Right. So it's all begging the question. Great circles are begging the question. It's all based on the R value that doesn't exist. Blah blah blah. Right. Right. Was known as the equator. Was known as the Great Circle. The equator is the only east-west line that is a great circle. All other parallels, lines of latitude, get smaller as you get near the poles, right? So the only real great east-west great circle is the equator, right? The rest of them are mostly north-south. What is true about great circles? Great circle has the same circumference or outer boundary and the same center point as its sphere, right? Center point as its sphere. The geometry of spheres is useful for mapping the Earth and other planets. The Earth is not a perfect sphere, but it maintains a general shape. All the meridians on Earth are great circles. That's all the longitude lines. What is the only map projection that accurately would show a great circle route? Why? The mnemonic projection is another member of the azimuthal projection family. Maps projected to a plane surface that is tangent to the globe at a single point. Right, the AE map, right, the most commonly known of those. And it has the distinction of being the only map projection on which any straight line represents a great circle arc, right? This is why I showed in my last video, right, the Gleason's map, because it's a longitudinal and time calculator. The longitude lines are the main great circle routes, right? That's what they're talking about. And when they want to use them, they have to flatten out their globe, right? because it makes the longitude lines a great circle, right? It makes the longitude lines straight lines. And as I've pointed out many, many times to many people on our opposition, and even people on the same side as me, when necessary, the longitude lines are exactly the same length, whether curved or flat, curved or straight. So that's why they can do that, because the longitude lines, as I said earlier, Eratosthenes, what did he do? He measured, right, a portion of a flat diameter. That's all he did, north and south, a longitude line, portion of a longitude line. And he then had to pre-assume it was a globe after that. But he didn't measure any globe. He didn't measure any arc. So, so as I said, and it's distinction of being the only map projection, this is the mnemonic projection, on which any straight line represents a great circle arc, longitude lines, right? A lot of people told me in my last video I was wrong, right? Do you know what I mean? This is where these people, they have zero research put in. They just are told something from someone else and they just start going with it. And they'd come around and tell people like me that I'm wrong, even though all the evidence is there for them to see that I'm not and what I was saying was correct. I said mostly great circle routes are longitudinal routes. And I'm correct. Why great circles are the shortest routes between two places, right? Great circles are the shortest routes between two places, as we can connect any two places on the Earth's surface by the curvature line of the great circle. And this curvature is the smallest possible route between those two places, because this curvature directly connects those places or points. What is great circle in navigation? Great circle navigation or orthodomic navigation, related to orthodomic course from the Greek right angle path, right, is the practice of navigating a vessel, a ship or aircraft along a great circle. Such routes yield the shortest distance between 2 points on the hypothetical globe, right? Longitude lines as much as possible, right? Or using the use of the longitude lines, right, as great circles. So you will obviously not always travel north-south. Most if you're talking about air travel, that's going across the equator, or that is any air travel that's going to be going across, that it has to go from one continent south of the equator to another continent south of the equator, like South America to South Africa to Australia, South America, blah, blah, blah. They all, like, with the exception of the claimed Sydney-Santiago flight, right? And I'm not going to go into that now. Other than that, they're all dog legs. They're all go north to then go back down south. So they go from south to north and north back to south. They don't ever go across. They don't go across. They take the longitudinal distance. They go up one longitudinal distance and then come back down another. This is what they, or they go towards the north, right, using a longitudinal distance, and then they go back towards the south using a longitudinal distance. They don't go up or down anything. Just, that's all they do. It's nonsense. What is great circle sailing method? A method of navigating a ship along the shortest navigable distance between the point of departure and the point of arrival. The shortest distance between any 2 points on a sphere is the circumference of the circle which joins them, and whose center is at the center of the sphere. Right, in the center of the sphere. What would that be? That'd be an R value. How would a great circle appear on a projection map? Great circle transforms to straight lines via the mnemonic projection. Since meridians, lines of longitude, and the equator are great circles, they are always shown as straight lines on a mnemonic map. Other parallels, lines of latitude, are depicted as concentric circles, right? Latitude, concentric circles. So there you go again, right? The majority of all these great circle routes, and I mean the absolute majority, are longitude lines. And now all these people on the globe side, all these people in our opposition, were telling me that I was wrong about this. As if I was wrong about this. And they even used the term, I said mostly or mainly north to south, longitudinal distances. And they quoted that exactly and then told me I was wrong. Why come these people can't do any basic research? What's wrong with them? Anyway, how is the Great Circle route different from the rhumb line as seen on the following map? Right, a rhumb line appears as a straight line on a Mercator projection map over long distances and / or at higher latitudes. The Great Circle route is significantly shorter, right, than the rhumb line between the same 2 points, right? So that's down to distortions on the map. When they flatten out the globe, it's down to distortions, right? It's not that, it's not that, what happens is that they distort the map. Like the globe is a distortion. So when they flatten it out, it's still a distortion. But what they do is they use the Haversine, right? And they'll be using a rhumb line, right, with their Haversine. And that rhumb line will be incorrect, but when they between the 2 points, but when they turn it back into a globe, it will give a correct distance along the arc for that piece of land, if you understand what I mean. But the thing about that is, our argument is not the distances along the land. The flat earth argument was never an argument about distances along the land, because anyone can measure them. They're measured all the time, a distance. Our argument is the claim of a globe shape, right, and the distance across the oceans, especially south of the equator. That's our argument. And all air travel, international air travel, supports. It always seems to support flat Earth. It never supports a globe, because airplanes wouldn't exist if we were on a globe for a start. But the routes they take don't support the globe. They give all kinds of east-west routes in the north of the equator, but south of the equator they don't. When they want to go from one place to one continent to another, they go up north. They go north, then they go back south. That's what they do. What is the relevance of the Great Circle route and rhumb line for air and sea navigation? Because of these adjustments, Great Circle routes are broken up into shorter lines called rhumb lines, which show the constant compass direction needed for the route being travelled. Rhumb lines also cross all meridians at the same angle, making them useful for breaking up great circles in navigation. How do great circles differ from small circles? A great circle is any circle that divides the Earth into a circumference of 2 equal halves. It's also the largest circle that can be drawn on a sphere. Small circles are circles that cut the Earth, but not into equal halves. When planning to cross an ocean, it is always best to use great circle sailing. Great circle sailing is used for long ocean passages. For this purpose, the Earth is considered a perfect spherical shape, therefore, even though they claim it's not. So there you go. This is the proof that it's purely mathematical. How could you consider the Earth to be a perfect spherical shape when your claim is that it's an oblate spheroid? You couldn't. In reality, you couldn't do that. It would distort things. But yet they can do it, because it's all maths. It's all purely mathematical. They don't have any measurements of anything. The shortest distance between 2 points on its surface is the arc of the great circle containing 2 points. Why is the circle known as the equator known as a great circle? Well, we kind of know that already. Well, I'll read it anyway. A great circle has the same boundary and same center point as its sphere. Center point, right? Radius. Great circles are seen on all meridians on Earth. All the lines of longitude meet at the poles, intersecting the Earth in half. Thus, a great circle always splits the Earth into 2 halves, so that the equator is a great circle, right, on the globe. What map projection gives a true direction for navigation when used at a global scale? The Mercator. One of the most famous map projections is the Mercator, created by Flemish cartographer and geographer Gerardus Mercator in 1569. It became the standard map projection for nautical purposes because of its ability to represent lines of constant true direction. Well, we know that the Mercator map does not fit the globe, because when Rob Durham put a circle of equal latitude onto a Mercator map and tried to then, in AutoCAD, 20 years of AutoCAD experience, try to turn it back into a globe, what happened? It got all distorted. So the Mercator map is not connected to a globe. I don't know what the Mercator map exactly is, but it doesn't represent a globe Earth. That's for sure. What is not true about great circles and great circle routes? Shape is relatively accurate. Straight lines drawn on them. Great circle routes are distances are not great. Run in a north to south direction, but measure distances east and west of the prime meridian. Right? So they run in north to south, but they measure a distance east to west of the prime meridian. So obviously there will be times when, especially north of the equator, when people are sailing or flying and they're going to be going from one place to another north of the equator. So they're going to be going east to west. They're going to be taking an east to west type route. But south of the equator, mostly they'll be going north to south. right? Because they don't have any choice. But so you would say, right, you're this much plus or minus of the prime meridian, blah, blah, blah. What two pieces of information you need to determine distance along a great circle? Knowing the rate, this is the thing. Knowing the radius of that small circle and the angle between the small circle radii to each place from the difference in longitudes, we can calculate the straight line distance along the two places using the cosine rule. What is the great circle in geography? Class, right, great circle drawn on a globe. It is the equatorial diameter of the Earth is the largest, blah, blah, blah. Right, what is a great circle name? Latitude, which is great circle. That's not so important. What's the main purpose of using map projections? A map projection is used to portray all or part of the round Earth on a flat surface. This cannot be done without some distortion, right? What map projection is most accurate? Orthograph, right? Right. I say that. I've seen that. It is a disaster, to be honest with you. Why do we need equal area projection? I don't know if it is the shortest distance between 2 points over a straight line. Blah blah blah. Microcircles is there on Earth? There are an infinite number of great circles that can be drawn on any perfect sphere. The longitude lines on a globe all form great circles that pass through the same 2 points, the North Pole and the South Pole. The equator is another great circle. What is the great circle distance deviation? The great circle distance or orthodromic distance is the shortest distance between 2 points on the surface of a sphere, measured along the surface of the sphere. Right, I think we got as much as we can get out of that. Now, the reason I pointed out a lot of stuff in that is this, right? I'm going to show you what Bob did, right? I know it's a bit of a longer video than I wanted it to be, but I'm going to show you what Bob did, right? In his response to me. What I called Bob out for originally, right? He tried to do the same thing, right? As a response to me. This is what he tried to do. It's really sneaky, right? I must think I'm totally stupid. This is the Goa Peters, right? Projection. Now, it doesn't show all the continents in their correct placements, but it's claimed, the claim, right, is that it shows the continents in their correct sizes, right? So these are supposedly the correct sizes of the continents, right? Africa is this size as opposed to Greenland being looking like on other projections like it's almost half the size of Africa. It's not. I think Africa is 14 times bigger. This is the actual width of Australia, supposedly. I haven't measured it. This is the length of South America, blah, blah, blah. Right? This is how North Ireland and the UK is. Up there is, here is Finland, I think, up here. So this is what's claimed to be the actual sizes of the continents. Now, what Bob did was this. He took this, right? Right. Sorry, don't mind that. Let's get rid of nonsense. He took this, right? This Gleason's map, because I used the Gleason's map in my last video to him. And what he did is he drew a line from the north here to Perth and the north to Sydney, right? Now, as you can see, if you look at the size of Australia compared to the United States here, I used to live in Australia, to live in Sydney, and I've flown across one section of Australia, right, 2 times, when I was going there and when I was coming back. Now, I've flown across the United States 4 times, right? The United States is, in my opinion, definitely a bit smaller than Australia, right? I would say I had a similar route across a kind of a similar section, and I would say that the United States is smaller. Now, when I flew, right, I flew from Ireland to the UK, right? And I got an international flight in London, and I flew this way. I think I went over part of Greenland. I did, and came down here along through Canada. I went down into Utah, into Nevada, and then into southern California. That was the route I took. It was basically a straight line, as much as you could make it, to there, from the UK to there. So I would say this is pretty accurate here. If you look at just this section here, the Gleason's map is pretty accurate for that part, right? Now, obviously, if we look at, if I just get this back down, if we look at this, right, Africa and South America look bigger and longer right? Australia looks, let's say, higher, let's just say, right? But not as wide, right? And as you can see, Australia is bigger than North America. It does look to be bigger than North America because you have North America and Canada up here. Now, North America may be a little bit wider, but Australia is maybe longer or something, right? It definitely seems to have a slightly bigger land mass. But either way, right? This is what is claimed to be the actual, right? What the continents actually look like in comparison to each other. Now, it's obvious that this here is obviously wrong, and it's admitted to be so, right? So Australia on the Glaciers map is admitted to being distorted. Now, I don't know whether it definitely is distorted. I don't know if that's the actual size of it. I don't know that. I would say it is distorted because the Glaciers map is a projection of a globe, right, flattened out. And the whole point of it is to make it into a longitudinal and time calculator, right? So what Bob did is he put two lines from Sydney to the North Pole and Perth to the North Pole, and he then did this, made a rhumb line here, right? And then he did use the Haversine formula using the radius of his globe that doesn't exist, and he corrected the distance across here, right? And pointed out that he says, now, see, the rhumb line is not the distance, but the rhumb line is a chord running through a sphere and through a circle. It is not a surface distance. It's a way of undistorting a distorted image. This is a distortion of a globe projection, and he's undistorting it by using the globe. But that doesn't mean anything. The argument is not the size of the continents, right? The argument is the placement of the continents and the distances in the oceans, right, south of the equator. That's the argument. So what all Bob did was the same thing as he originally did. And what he originally did was this, right? He went from Chicago, I think it was, here, to, I think it was Denver, right? Somewhere like that down here, or Phoenix. And he put a rhumb line, right, on that, right? And then he used the Haversine formula, which then added or, right, which gave a more correct distance. Because the reason it gives a more correct distance is because the globe projection has the actual distances as close as possible, right? Or the claimed actual distances as close as possible to reality. But that doesn't make the Earth curved. It means that your correct distances are curved on your globe. They have to be. You can't have flat distances on your globe. So, but all that doesn't matter because there is no radius value. There is no R measured to use. It's complete and utter nonsense. And that was my original point. You can't use the Haversine formula without an R measurement, that doesn't exist. So I called him out originally on using this straight line here and claiming, a straight line distance here somewhere. I'm not sure if it was exactly there, could have been like this or whatever. But I called out Bob on that and claiming a rhumb line, which is a chord, as a straight line flat earth distance, right? Which is not correct. It's not a surface distance. It's basically a chord through a circle or a sphere. And he was trying to compare that to, basically all he was doing was undistorting a distorted globe. That's all he was doing. And that's the whole point. And he's trying to do the same thing over here. He done this nonsense over here, put that here, put that there. And then he showed then that Australia was not as wide as that, or not as long as that, right? And he tried to use that again. It's just the same ridiculous trick that I was calling him out on. So he must think I'm totally stupid. This is claimed to be what Australia looks like. This is obviously a distortion, because this is a globe map, right? Flattened out. So it's distorted. So he's undistorting his globe using globe maths. But what has any of that got to do with reality? In reality, there is no measured R value, right? Rhumb lines are not straight line distances along the surface of Earth. These were my 2 points, and he didn't address them at all. So Bob, unless you want to address those 2 points, how there isn't an R value measured anywhere for the Earth, and how you're using an R value, and how you're using a rhumb line, which is basically a chord, as a straight line distance along the surface, when rhumb lines are not surface, they're not a surface measurement at all. They're used within the Haversine formula to undistort a globe projection back into a globe. That's all they are. but you need an oar in reality for the Earth to be a globe. You don't have one. So that's the end of that. Thanks for watching.